Hey, welcome all of you for this live session for Smart Grid Basics to Advanced Technology course. My name is Gagan Meena and I am one of the TAs for the live sessions. There are 3 TAs for live session for this course. And I am a 4th year PhD student at IIT Bombay. Let us begin with today's session. I hope you are aware that there are 2 other live sessions also. One is on Saturday, one is today, and another one is tomorrow. You can attend any of these live sessions and and clear your doubts, whatever you want to ask, and understand the things. And so let us start with today's session. First of all, I wanted to know, because this is the first session, what have you would be having some expectations, and how do you want this session to go along? Uh, can you, any of you can you tell us how do you want this session to go? Because there are in lectures there are 5 videos, and each. And first of all, the first question is, how many of you have watched? Have you watched all the videos, the content which is available on the portal?
Me. I watched all. Okay,
Yes.
Smart. Week 1.
You watched only week 1. You can raise your hand, those who have watched the sessions. Okay. 2, 3. Okay, so 3 of you have watched the sessions. Thank you for replying. 4. Okay. So that's why we have a mix of crowd. Some of you have watched, some of you have not watched these sessions. So that's why I'm asking, how would you want me to go along? Means the way I have decided is maybe a little bit different from what you are expecting. So do you want me to summarize the week and then discuss the questions? So you want a short summary or a very elaborate summary? That's the question.
Yes, sir. You could give a summary of the content and then recap of the questionnaires. Like that would be of support, I feel.
Okay, and the way I do, I have been doing these sessions same way, and I try to summarize the content of the week, not the entire content, but the main points. And while discussing the questions, some important topics I again cover, which are left while discussing the summary. And I also add up new some things which are not given in detail in the weeks, but we can discuss here, and some new updates also, because these lectures were developed in 2017. So after that, the content, some facts have not been updated. So that also will I have updated, so that we will discuss. Let us start. If you have any other suggestions, you can always feel free to speak, and you can ask questions in between also or after the sessions. Okay, so this is the way I have designed these live sessions. The first we'll go through the overview of week 1, and then after the overview we can discuss some questions. And while discussing the questions, also some topics related to those questions we can discuss in detail. I have added some extra material for that in the presentation itself. And then also after the questions also you can ask the doubts. So this is the way I have thought of. If you have any suggestion, you can always. Okay. Also, to remind you that the deadline for assignment 1 is February 5th. Please submit the assignment on time. And you will find the link for all the live sessions on the portal itself. On the left hand side bottom, you will find a problem solving sessions tab. I hope you can see that. Has anybody accessed that yet? No one?
Yes, yes.
Yeah, so you can find all the links for the YouTube videos as well as the PPT or the presentation or whatever document the TAs are using. You can access that also. And the Google Drive link is available on that portal. You can always access that. So let us start with the overview. This course is about smart grid. So that means earlier the grid was not smart. So can you tell what are the key components which have been added or which we are trying to add to make the grid smart? What?
Monitor
Sorry.
monitoring, like you can
Okay.
monitor and
Yes.
Control system.
Okay. So good. So two inputs we have received: monitoring and control. So we have been doing this monitoring and control earlier also, since the power system has been there, especially in 1960s when the SCADA and when the communication system came into being and the SCADA system was developed. So in 1960s, this control center you would see on the screen on walls. There will be now we can see very elaborate control centers, but earlier there were on the walls there were these pen recorders. So just like she pointed out, Shakshi, I think Shakshi, you pointed out. So we used to monitor, like if you want to monitor the voltage, then there would be some recorders, pen recorders. You would have seen in some videos like earthquake, the stylus is there which is moving and which is noting down on the Richter scale. Such types of pen recorders were there. At the early in the initial phase of the control center in 1960s. After that, everything gradually it changed. So we were monitoring the system during earlier stages of this monitoring and control system also. But what extra we are adding now? That was also part of a smart, but now we are adding something else. Even you would say it is more sophisticated than it was before. So earlier those were mechanical things, and now and the speed the frequency at which we would receive the data was also limited. And we could not observe everything because everything was hardwired at that time. But now we have communication infrastructure. So much elaborate communication infrastructure is there. We have wireless communication also. And from SCADA, we have even moved to PMUs. And because of that, or we call it wide area monitoring system. So entire India we can monitor. Do you know what who is the ISO for India? Independent System Operator for India? Anyone? Which organization or entity acts as the independent system operator for Indian Power Grid?
POSOCO.
Any? Yes, correct. So it is now Grid India. Earlier it was POSOCO. Now it's Grid Controller of India Limited. That is also our National Load Dispatch Center and also the system operator, which is monitoring everything. So we can monitor entire Indian grid there. They have entire control system, everything we can visualize now. Each line we can not each and every line, but we call them flow gates. Let's say there are between two centers, two demand or two buses, there are multiple lines. Then we combine them using one single corridor and we call them as flow gates. We can visualize all those flow gates for and the entire grid on one screen or multiple screens also. But yes, we can visualize everything. We can monitor, we can see what's the flow, is there voltage violation. All these things are possible because of the deployment of PMUs now. Earlier we were having SCADA system. We still have SCADA because the PMUs are not installed everywhere. There's phase 1 of PMU installation is over. Now phase 2 is going to start below 230 kV transmission, these voltage levels. Above this, we have PMUs at all the substations. So anyone of you, so can you tell the difference between PMU and SCADA? We can say earlier the system was also being monitored and it was also being controlled, but earlier the controls were, now everything has become more sophisticated. Now, first of all, the communication system has improved a lot. We are now moving into sixth generation, 6G communication. So the broadband, the bandwidth of communication has increased very much. We have the speed of communication, the latency has reduced. All these things have enabled faster communication, both wired and wireless. And then information technology has also come up. All these devices, different types of sensing devices, and then their uh, associated infrastructure, all that has come up. And apart from that, plus use of these, because when we have meter at each and every point, transmission system is still, we have number of buses are limited. We would say around maybe 8,000, 10,000 buses are there for the entire Indian power grid. The transmission for transmission at transmission level. But if you go to distribution level, then in one city itself, there are lakhs of buses, lakhs of consumers. And if you model the distribution system at such a granularity, then we need to, if you want to control it and monitor everything, just as we monitor transmission system, then we would require lakhs of devices. And that would require the communication system bandwidth to be huge. The communication requirement will increase tremendously. That's why right now we don't have that much communication infrastructure. Even in US, recently one professor had visited here, so he was telling they were working for on a project for monitoring distribution system. So this is one of the challenge. How why we are trying to move towards making the grid smarter and smarter, but still there are many challenges. Like one of the challenges which he told that communication is a problem because they don't have sufficient bandwidth. You see, we'll discuss smart meters. They provide different types of data. They provide energy consumption for a consumer. So kWh, and then instantaneous active power and instantaneous reactive power, then RMS current, voltage, and power factor, phase angle also. So phase angle is known, then power factor is also known. All these things can be provided by a smart meter. But because if we want to communicate this much data for each house, each consumer, then it would require a lot of bandwidth because you're saying instantaneous voltage and current. Even if the frequency of measurement is let's say 1 second, then in one day we have 3600 seconds. So we want 3600 values for active power, for reactive power, for current, voltages, for one home it only. The communication requirement is, the bandwidth requirement is quite high. That's why the companies, they were only providing this energy and the voltage magnitude. That's the RMS voltage. So energy and RMS voltage. But if we want to monitor everything, then we need the active power and reactive power consumption as well. So, so they had to only use this energy data and voltage magnitude to do the analysis. They were using some machine learning techniques. That's why. So communication sophistication, information technology, and then the use of, when we have so many meters placed everywhere, then we need to analyze that data. For that, we need these big data analytics. All these techniques are also required for that. Earlier, these techniques were not there. So after the advent of this machine learning, the AI era, we are in a position to, first of all, that's where the simultaneous advancement in these communication, information technology, and this AI ML, they have enabled us to monitor the system at a smaller scale. Even distribution. That's why we are talking about distribution system automation now. Earlier, there was no such automation. And there is one more reason why we are talking more concerned about distribution system. Can anyone tell? I think all of you are aware about that. That main reason why we are now more focused on distribution system. Anyone? Renewables. I do think the if each and every house has a PV panel, will that create any problem in system operation? Is it fine? The integration of distributed energy resources. Right now, we are only talking about this. We have only this solar, rooftop solar, and now even you can say an electric vehicles also. Still, we are not operating in the vehicle to grid mode. We are only charging the vehicles. But then, even these two are also, if their penetration increases in the distribution system to a great extent, then there are reverse power flow problems that we will see in subsequent weeks. That what is the problem for protection system, challenges to protection system due to this bidirectional power flow. The entire protection scheme which we have been using till now needs to be updated because of that. There are issue of, earlier we were only concerned about the voltage drop issue. Right? Voltage drop issue at the far end of the feeder. If we have a substation and then there are several feeders, there can be laterals also. These are laterals. And this is the far end, the last, the end of this feeder, this main feeder. And we were concerned about the voltage at this, let's say this is the nth bus, so Vn. This is substation. We were concerned about the voltage drop at this last node, nth node. But because of, and that's why we had to maintain that voltage by using these different techniques. OLTCs are used. In India, we don't use volt var compensation for distribution system or CVAR. But in US, they use it. We were concerned about that. But now the another problem is voltage rise problem. The voltage here is not less now, it is even more than the substation voltage. Now Vn is more than substation voltage, especially during the daytime. Then solar peak is there. Because it is generating excess power and it is feeding it into the grid. And the voltage is rising. That is another problem, which we were not facing earlier. And this problem has been witnessed in several grids in even in India and in IIT Roorkee also. This problem was there. It was seen, so they designed certain. Then there was a project funded by DST and also Indo-Danish project. So in that, you will see in the next the subsequent weeks that suitable places for the energy storage were designed so that that excess energy can be extracted from solar and can be stored, which can be used later in the evening time. All these problems are coming up, and in India, still the rooftop solar penetration is not that much. But now the government has announced, so it will increase. But there is one grid where Australia is such an example where 50% of the demand at certain times of the year are met by only rooftop solar. Let's see, 50% is too much. It's quite large. Their rooftop solar penetration is quite high in Australia. So in future, we would also see that kind of situation. And not just rooftop solar, there are also now people are coming. The companies are coming up with micro turbines, micro wind turbines. You can have at the rooftop wind turbines. Gradually these penetration of different types of DERs will increase in the system, and that will create problem because then the distribution system earlier, the distribution companies, they knew the load pattern. By their experience, they knew what kind of load is generally there, and if even seasonal variation was also very well understood by them. But now, because everything is behind the meter, all the DERs, electric vehicle or energy storage, all these are behind the meter and they don't have visibility. So prediction of demand becomes very difficult now. That's why we cannot do it simply by our experience. We have to use these techniques, these machine learning or AI techniques, to handle such a large quantity of huge amount of data and to extract some meaningful information out of that. In this week, the main points which were discussed was this architecture of smart grid and different standards for smart grid and different elements and technologies which are used for making the grid smart. Here, these things were discussed. First, grid components that we have already seen, and a brief history of power grid, which most of you might be already knowing, so we are not going through it. An evolution of Indian national grid. Earlier we were having regional grids, then gradually we combined each one of the region with the other, and then finally we had one. Now we have one synchronized grid. Can anyone of you tell how do we connect two regional grids which are operating at different frequencies with one another? Because in one AC system, one single AC system will have only one frequency. The system will operate only at a single frequency. But if two regions are operating at two different frequency, and then how can we connect them? Is there a way? Or do we see this? We have these 5 regional grids. Uh,
through HVDC.
yes, correct. Through these back-to-back HVDC connections, we are able to do that. On both the ends, the frequency can be different, but because they are linked with DC, there is no frequency component. We are able to achieve that. And they also help in ensuring maintaining stability margins also. There are if other uses also. And we also use HVDC for long distance transmission. So finally, we are now having a single grid. Then different regulatory authorities were discussed. Like we have NLDC, the National Load Dispatch Center, and then we have these 5 regional load dispatch centers. Is west, north, south. Then which one is left? Eastern and north.
Northeast.
Yes. East and northeast. So these 5 we these regional load dispatch centers are there, and then each region has number of states, and each state has its own SLDC, the state load dispatch centers. So this is a hierarchy. So the demand profile which a discom, let's say Maharashtra. So right now I'm in Maharashtra. So Maharashtra SLDC is there, state load dispatch center. In Maharashtra, there are different distribution companies. The major distribution company is Maharashtra Discom, MSEDCL. So Maharashtra State Electricity Distribution Company Limited. And then there is Adani Power. Then Reliance is also there. And one BEST is also there. So these are the major. There are some few very small distribution companies also, but these are the 4 major. And mostly out of, if we say around the peak peak demand of Maharashtra has been maximum up to 30 gigawatt, then around 26 to 28 gigawatts is the share of MSCDCL. So MSCDCL is the major discom here. So they will provide the demand forecast. Each of them will provide the demand forecast to their respective state load dispatch center, and then they will ensure that for that demand next day, the system will still be able to manage the generation profiles. They have to schedule the generators within the state. There are different generators. So Maharashtra State Power Generation Company Limited, they have their generators, and then there are different independent power producers like Jindal Steel or Jindal Power is there, or Adani has its several thermal generation. Even Tata Power also has. These are independent power producers. And then we have central sector generators, which are NTPC generators, thermal generators, NHPC, nuclear power, all these generators. Hydro is also there. Then renewables are also there, inter and intrastate. So all these things are the demand plus the available generation. They have to ensure that it will meet. The balance will be maintained subject to the network availability. Plus, they have to also ensure that in case of contingency, this will still work. Even if there is a loss of one big generator or one network corridor, then still the system will be able to meet the demand. So they do this kind of study. And then SLDC will give it to RLDC, and RLDC will give it to NLDC. This is the hierarchy. So finally, NLDC does this for entire country. They also monitor the market. Uh, so we have 3 power exchanges in India. So can anyone of you tell the name of these 3 power exchanges where we trade electricity? Anyone, if you remember?
IEX.
Okay, yes, IEX is the major. The most of the majority of trade happens in IEX, especially DAM, the day ahead market, and RTM, real time market. Most of the trade happens in IEX only, 99%. In term ahead and other green day ahead, other two are also there, but most of the 99% of trade happens in IEX. Then this is the major power exchange. Then there are 2 more. Anyone who knows? One is Power Exchange of India Limited and one is Hindustan Power Exchange. So every day we are using right now electricity, and we are sitting here, we are having electricity and we are using it for different purpose. But for that, each day, even for each 15-minute time blocks, 24 hours, we have 15 minutes time blocks, 96 time blocks. And for each time block, the operators are keeping a continuous watch such that the demand and generation is always within a certain band. The deviation is within a certain band, because as soon as this deviation increases, the frequency will vary, and that has to be kept within a, but a band. Otherwise, it will lead to instability, a loss of synchronism, and even blackout can happen, and which we have already seen in 2012. All these things are done by these different, so NLDC, SLDC, and all these things. They are each for each and every time blocks. They are continuously monitoring the system, and then there are different authorities which make plans. Like we have Central Electricity Authority, CERC, and for transmission planning, CTU has been taken out from power grid. Earlier, it was a part of power grid. CTU and state transmission utilities, they will make transmission plans. CEA makes the generation and entire holistic plan or national electricity policy, and that MOP is there. All these things, different regulatory authorities are there. Together, they are trying to make this grid work. Then we saw what makes a grid smart and different smart grid components. So these are the different smart grid components. So these are the four major. You can divide this component into four parts. One is smart infrastructure, smart communications. We already discussed communication is a very important requirement. Then smart management and smart protection. Because the grid is changing, we are seeing we need a change in the protection schemes also. For that, and the protection, even so earlier for protection, if we, let's say, for distribution system, we had this overcurrent relay. If the current is beyond a threshold, then the relay will operate. And we just, once we set this threshold for the relay, it will work for a long time. But now this thing will not work because of the renewable penetration, even the different you would have heard about this grid following grid, different types of inverters, grid farming, grid supporting, grid following. Have you heard of this? These three terms? So depending upon these modes of operation of inverters, the fault current also changes. All these things will now one particular threshold will not work. We have to adaptively change it depending upon the system configuration. Topology also changes everything because bidirectional current is there, topology changes, current flow also changes. And the mode of operation of inverter also governs whether the system is operating, is it connected to the grid or it is islanded. That also determines the fault current. So there are so many parameters now which determines the fault current. So if the system is connected to the grid, then the fault current is different. If the system is isolated and it is working as a microgrid with different DERs, storage devices, then the fault current is different. For both the scenarios and for different penetration of RE or different modes of operation of inverter, the protection scheme should be agnostic of all these different changes. And for that, we need adaptive protection schemes. That's why we call it smart protection, which can detect the change in the system and adapt itself and still protect the system. And it can again reconfigure it when the system is again connected to the grid. All these things can be done and are being developed, although all these things are there in the paper, but to implement them in the actual distribution system requires a lot of changes to be done, especially the communication system. And another challenge, one more challenge with communication system, you see, even if we have communication system, let's say we have meter at each at every house, then also there are many challenges. There are problems of bad data, noise in the measurement, and then there are missing data also. Sometimes continuously 2 3 weeks data is missing, and it becomes very difficult to analyze. And still we want to do it. And still That's even with these missing data, there are different probabilistic techniques which are used to generate a profile based upon the historical data of, let's say, two houses are there. House 1 and house 2 is there. For house 1, I have a historical data for, let's say, 6 months. Complete data. I have complete data, and these two houses, their load profile is almost similar. But for this second house, 1 month data is missing. Because of, let's say, communication failure, channel, something has happened, and it happens. Now we can use this historical data of the load, which is having similar profile, to generate the this 1 month missing data for the second house. It's possible. Uh, that for such types of techniques are used, but these are challenges. The practically, if we go to field, then there are many challenges that we come across. Even if we have the entire system in place, there will be challenges. We have to uh, take care of these different types of bugs and make the system foolproof. Okay, so smart infrastructure, communication management, and smart protection. So in infrastructure, we have smart energy system. This was the system which we already had, right? Generation, we already had transmission and distribution. This was the when we had, even when the restructuring of our system was not there, everything was there. Generation, transmission, and distribution. Everything was owned by one single entity. That was virtually the vertically integrated system. But then the different entities owned different these three assets. Now we have distribution companies for taking care of distribution system. We have transmission PGCIL in India for interstate transmission, and we have state transmission companies also for the intrastate. And then we have generation. We have so many companies now, NTPC, NHPC. These are government companies, and each state also has their own generation. So now each of these three are they are decoupled. We were when renewable penetration was less, not that much, we were able to work with this. But now we have renewable penetration at each and every level, each and every voltage, almost all the voltage levels of the transmission system, as well as on the distribution system, as well as on the generation side. So, can you give any example of renewable system on the generation side? And have you come across this? So now earlier we were having the generation only at the top. If we talk about the power flow in from top to bottom, from generation to distribution via the transmission. Let's say this is the final our consumer, and this is a distribution system, and this is a transmission system, and here is the generation. So earlier we were only talking about the power flow from generation to the final load and to the consumer. Let's say we are consuming the power right now. We are doing this video conferencing. So we are using that, and it is coming from generation. So earlier generation was only at the transmission level. But now generation, so we were only talking about the thermal generation, hydro generation, and nuclear generation. But now we are saying the renewable generation is there everywhere on all the three levels. The renewable generation is here also in the form of DERs. It is there at, let's say, 11 kV also. It is at 33 kV, 66 kV, up to even 400 kV or 230 kV. And So my question is, do we have, so this generation voltage is less, right? Do we have renewable on generation side also? Have you come across this? Distribution, we all know solar rooftop is there. Transmission, now big solar farms, wind farms are there. But do the generators also have renewables now?
Yes.
Or are they planning to do so? Have you come across this in anywhere in news or somewhere?
I see NTPC Dadri has this this that the solar reflector mirror type of concept.
Solar
But
thermal.
I do not know it's operational under operation or not, but
Good.
was there.
Yes. Yes, you would have, we will see in the week 3, I will show when we will study that solar and wind technology. I will show examples of these solar floating plants.
But I think in the as well as the this generation side, maybe small utilities can be used from the generation, but with like rooftop solars or small scale solar.
Yeah, that is true, because on even generation, when we talk about generation, let's say it's a big, when we are talking about a 200 megawatt, a 500 megawatt
Yeah,
generation
it's
plant, then
spread across like 25
it's a big,
square kilometers of the area. So
yes,
they have
correct. So
used
it's,
this place to put up some solar and other
yes.
utilities.
Even they have rooftop solar plants also.
Yeah,
Every
yeah.
each they have. But now the government has mandated that the new coal plants which will be coming up, they have to have a percentage of their installed capacity to be met by renewables. So they will have to build a plant also. And you'll see in the week 3 that NTPC Ramagundam, so they have a solar floating plant around, I think, 90 megawatts or so. Similarly, there are other other plants also. But if now, because the thermal utilization is also, the utilization of thermal plants is also reducing, because in daytime, and their ramp requirement is also increasing. In daytime, the solar penetration is quite high. So before in the morning, they have to ramp down, and evening they have to again ramp up. And they are also trying to reduce the technical minimum requirement. Right now, it is 55%. Let's say if a thermal unit is the rating install capacity of a thermal unit is 100 megawatt, then it cannot be operated. It is not economical to operate it below 55 megawatt. Right now, all the thermal units, they have this minimum requirement. Now they are trying to reduce it because of this flexibility requirement which we have. So much ramp, around 6 gigawatt, 8 gigawatts of ramp is required within few time blocks, which is very high, very huge. For that, if they have solar plant and even storage, battery energy storage also, then these things can be mitigated. Okay, so yes, on generation side also we can have renewables and storage. Now we have storage also at all these 3 levels. Like distribution side, we have behind the meter battery system, behind the meter energy storage, and we have electric vehicles also, which are also they have batteries. On distribution side also, now we have in Delhi, Tata Power has installed, I think, around 10 megawatt of battery energy storage. And even NTPC, different companies, they have also installed small energy storage in distribution system for voltage, improving the voltage profile, and all these things. Then in transmission system, at transmission level, energy storage is coming up. So many projects are there in India also now. One project is there of in Leh, Leh, Ladakh.
So one question, please.
Yes, yes.
So these batteries and this, I don't know, quick response, these technologies are mainly for the ancillary service, not to like giving you as a proper supply.
Oh, energy storage are of different types. But what you're saying is correct. There are different types of energy storage and there are different technology of energy storage. And each technology has its own utilization. There are two broad classification. One are some technology, they are energy, they have good energy density. And some have good power density. So those which have good power density, they can be used for ancillary services like flywheel, supercapacitor, and some battery technologies also can provide that kind of ancillary services. But some other technologies, they have good energy density. So they can provide uh, power for a longer duration.
Like as an example, maybe.
Example, sodium sulfur is one example. So in even lithium ion is also used for long duration. Like right now in world, if you see around the world, 2 hour, 4 hour batteries are common for lithium technology.
So even
In
evening time peak hours can be covered by them, right?
yes, yes. So, in Australia, we'll find mm Australia has a good penetration of energy storage, a very huge penetration of energy storage, and they are even planning around 3 GWh. Recently, Dubai has entered into a. They want. We have used this base load term for thermals, right? Even nuclear or thermal. When we talk about base load, we refer to these type of generators. But now Dubai, what they are saying, we want to provide 1 GW of base load with solar.
Okay.
A 1 GW of base load solar. For that, they will require 19 GWh of storage. So they are building a 5.2 gigawatt of solar plant with a 19 gigawatt hour of energy storage. So that will provide a 1 GW of base load. Round the clock uh, supply, 1 GW
So
throughout
they're
24
actually
hours.
eliminating the concept of this peak load prices and other things, right?
Uh,
I
uh,
mean, they're just trying to this is the optimum. What do you say? My
Actually,
target, my goal.
so 1 GW is that is the base, but in between, means it minimum 1 GW it will provide. But in the when solar is there in daytime, it will be even more than 1 GW, and that energy will be even after storing it in the storage, it will be more than 1 GW during the daytime.
Why I'm asking because in UK,
Yes.
2022 they had till 2022 they had this called triad charges in the transmission system.
Hmm.
The triad charges, how they are calculating it in a year, mostly in winter season, because in the winter season they have the most consumption. Between
Yes, yes.
between December till February, they will randomly select 3 days, and in these 3 days they will randomly select 15 minutes, and in these 15 minutes they will I'm sorry, it's 30 minutes. In 30 minutes they will see the total peak capacity of, 3 times in this particular period, and they will calculate your total yearly charges for among them and the bike. It's a different mechanism how to calculate it, but this is the concept of it. Now they are saying this, we will eliminate this, so there will be no triad charges. Instead of it, we'll have a like normal concept like in India. um, whatever your consumption is. So our ultimate goal is to eliminate these peak charges and all that, this peak concept of the thing. So we'll have a linear steady base load. That's
Uh,
what it is. I mean,
yes,
my
agree.
understanding, maybe I'm wrong, just
Uh, yes, what you're saying is correct. Means we have been trying this for since we had started with this generation. We always wanted to have a flat load profile, always.
Yeah.
But
There's
we could
yeah,
never achieve that.
flat
But
load
we all
profile, right.
still now also we want that because if you see now the requirement of this means to sorry uh, yes earlier the profile was maybe something like this. Now you see the profile is like this.
Dark curve, right? I call it.
Yes, it is duck curve, or even recently one paper they call it a canyon curve. Even the duck is becoming more steeper.
Mhm.
These ramp down and ramp up, these are becoming like canyons. It is becoming more steeper, and earlier this this trough it was above zero, and now this is going below zero. See, when the generation is more than the demand during few hours, it is happening in California, even in other grids also, Australia, California, it is happening.
Yeah, in the office time, daytime, it's not. They're not going to use that much demand. It's not there.
Right now in India, we don't have this scenario that negative demand we are not having, but in future, as the renewable penetration increases, the more and more solar we are trying to integrate, this we are going to see. Then, and this is leading to negative charges, negative
That's
market prices.
yeah. In a few days back, Germany has this sort of a huge negative unit cost in the day-ahead
Now,
price.
European and US grids, they are experiencing negative prices because of so this renewable penetration, high renewable penetration. Recently, there has been a report by IEA. You can means it's a good report. You can read it if there are. It talks about 6 phases of. I think I don't know whether some of you have come across this 6 phases of renewable integration, high integration. So countries like Denmark, they are in phase 5.
And I think they have almost more than 70% of the renewable generation.
Yes, because they have huge wind farm
And also, they are
capacity.
also supplying their capacity from, so it's called the Viking link actually to
Yes,
UK.
yes, correct. UK.
And
And there has it has been in
about
news for
2 gigawatt, and currently its operation up to 800 megawatt, if I'm not wrong.
because recently it was in news because of failure. This Viking link uh, because of failure, because it's a huge corridor, and if it fails, then the frequency fluctuation is, you can see 1 gigawatt of sudden drop in the load. Then there is a there has been so much many instances of frequency violation in UK in last 2 3 weeks because of this Viking link. So all these
Okay.
things, all these problems are now increasing because of this renewable penetration. So now the system is not as which we have been operating till now. It is changing rapidly. We need to deal with, and for that we need to evolve our strategies which we have been using till now. That's why this course is, the main objective of this course is to understand what are the challenges, and to get an idea that yes, the technologies, the algorithms, or the methods which we have been using, they need to be adapted. So this course is to give an idea for all these things. And on all the generation, distribution, mostly distribution side, where this course is focusing more on distribution side. But transmission system is already more of smart, because we are mostly now transmission system. Can you tell some challenges in transmission system? US is worried about one major challenge. Can anyone of you remember, or have you come across the main problem with the US transmission system? And for that, they have come across a solution also. Some It was there in paper, IEEE magazine also, and several countries are thinking to adopt that. There are many research going on to how to use the existing transmission system to its fullest. The major problem with US transmission system is its aging infrastructure and how to reduce the cost without complete overhauling. Because if we want to upgrade the existing infrastructure, to build one transmission line, it takes how many years? It takes several years. And if you want to upgrade the entire system, then we can just imagine how much time it will take. And also the cost is enormous. So for that, there is one term, and you can see, since I am telling all these terms so that means you can come when you read, you can come across all these. You come across these terms, you can just to give a thought and to make you aware that so many things are now going on to make our power system more advanced and more reliable. Now things are changing at a very rapid rate. There is one uh, concept called reconductoring. Use the same tower but change the wires. And that too, right? Till now we have been using these wires, like, and we have strands, right? And these were cylindrical strands. But now they are talking about poly in the shape of a polygon or squares. The polygon would be a general term. So
Sorry, any
and
specific reason for that?
yeah, that is they have found that it improves the overall performance. The transfer capability improves. The reason why we went for this stranded and why do we have so many strands? The same reason, same thing applies there, but it is even more efficient. That's why they are moving to
Isn't it?
that.
I think I'm not an electrical engineer, but still I'm just asking. It power flow through the surface, right? Not in the center, but still, if we have the cylindrical, it will it will be more compact and more cost efficient, right? I think.
So I have not read that paper, but yes, well, I will
It
have
just
to
comes
go
to
through
my
it.
mind. I
But
mean,
yes, yes. But I'm just giving an idea that you can search about this also. So this is one of the method which they have come across, and then another method, dynamic uh, line capacity estimation. For that also, many devices have been developed. So we can get the real time thermal rating of the line so that we can optimally utilize it. Okay, so yes, now renewable is everywhere, even energy storage is everywhere. On generation side also, we have energy storage on transmission level and distribution level also. Everywhere we have both these. Now government has also mandated in the CEA plan as per 2030 plan. They're planning, they have envisaged that the storage will be all the solar plant developers, they will also have energy storage so that they can provide around the clock output. Then we have smart information system. Here we have smart metering, smart sensors. Sensors will have, they will provide us the data. And then PMUs. Earlier we had the SCADA. The rate of PMU is quite high. It's quite large. The PMU can send us a number of 20 to 35 samples per cycle, but SCADA would give it within seconds. So there is a difference between the rate at which these two system operate, and this is one of the challenge how to, because we know SCADA, the data which we get from SCADA is used for state estimation to know what is the state of the power system. And if we replace SCADA by PMU, let's say in 8,000 buses, 1,000 buses or not even 1,000, 500 buses are having PMU, rest 7,500 buses are having SCADA. But the rate at which these two problems are there. The rate at which they are providing data is very different. Second, the data which we are getting from SCADA, it is not time stamped. We don't know the particular sample corresponds to which time instant. So how do we compare the two data if we don't know? We can only compare when the two values belong to a particular time instant. But if they belong to different time instant, then that is of no use for us. Then PMU, the advantage with PMU is that each and every sample is time stamped by GPS signal. By using GPS, they are time stamping it. That's why we call these phasor uh, synchro phasors. So the phasors are synchronized, time synchronized, and that's why we are able to get. And also the computationally, mathematically also, if we see the state estimation which uses SCADA data is non-linear. We have to use Newton-Raphson, then Jacobian. We need to calculate Jacobian and do the iterative procedure. And it is. So this is non-linear, but PMU, it gives us a linear state estimator. We can solve it even much very quickly. These are the advantage of using PMU over SCADA. But because PMU is costly, we have not replaced all this SCADA with PMU. And now the challenge is how to combine the data of SCADA and PMU together. So this is also a research problem, hybrid state estimator. Then distribution side also we are thinking of these distribution PMUs, DPMUs, but they are even more costly. They are very costly. One professor told that four distribution PMUs cost him $30,000 just for PMUs. That is too much. So gradually it will cost will reduce, but now we have to combine these two data, and for that we have to make algorithms. So PMU is an information management system. So these are the four main components of smart grid, which we have talked. And then smart metering. So in smart metering, we have this advanced metering infrastructure, and this is the building block of smart grid. When we are saying smart grid, the main component is a bidirectional, just because we have a bidirectional power flow, and we also have the bidirectional communication, the two-way communication. So even the consumer can interact with the utility. Utility can give some commands to the consumers. The inverters, the solar inverters, they they have communication capability. The utility can use, if the utility and consumer they have an agreement, then utility can control their inverters to maintain the voltage profile in the feeder. So all these things are possible when there is a two-way communication. That's why the things for making the smart grid we need. With all these things will happen in stages. Gradually, we will be adding one component. So there are so this advanced metering infrastructure, in this also this two-way communication will be it's it's ideal, or we would say the best would be to connect each of the meter, each consumer meter directly with the utility, the meter data management system, the utility control center. But we have already seen that communication infrastructure is not that good. The bandwidth is not that much that we can have this type of communication. We even don't have that kind of communication right now. So that's why one option is to aggregate certain meters, and these some companies can provide this service where they can aggregate this. This is meter concentrator, and then that will provide the that data to the utility control center, and then the same two-way communication can be ensured. So that it's an immediate intermediate step. And some countries they have such type of arrangement. We don't have right now. We don't even have smart. We don't even have prepaid uh, connections, electricity connections. Have you heard of prepaid connections? Just as we have mobile phones, we have both prepaid and postpaid options in mobile phone. But we don't have that option right now in India. I think I don't. I have not seen. Have you seen somewhere? But it is there in European countries. In UK, it's in many countries it is there. If you are just as we have this DTH, in that we have a card and we have to recharge it. If we don't recharge it, then we cannot see the channels. We cannot access the content. Similarly, that smart meter will have a card, and that card, if it is not recharged, no electricity, and we have to recharge it. So this is a first step in going towards smart grid. Okay, then yes, we already talked about this, that smart meter measurements, so many measurements are possible from a smart meter, but because of communication requirement limitations, we even don't have access to all these data. Then PMUs also we have talked about. There are many benefits of using PMU. We can, the foremost requirement or foremost uh, application of PMU data is for state estimation. It can be used for monitoring power quality, disturbance location, monitoring fault events, for fault diagnostic, fault identification, fault localization, and then even for any kind of, in many studies are there which use the PMU data for even preventing or preventing any kind of blackouts. So providing loss of mains protection and monitoring active distribution networks. So for this, we will require a distribution PMU. Okay, then smart communication. There can be we have, this is the backbone of a smart grid, and it can be wired or wireless. And in wired, we have fiber optic power line. And in wireless, I think some of you would have come across this now. Air fiber, have you heard of air fiber? Many companies like this Airtel and Jio, they are providing air fibers now. Earlier, they were providing optical fibers, but now they are providing both. Now, for optical fiber, you need to They need to lay down the fiber cables. But for air fiber, that is not required. There is a small box which is connected through satellite. It's wireless. Then we saw the different architectures of smart grid. These are the 7 main components in smart grid. We call them in computer networks terminology. These are called domains which interact with each other. These that's why these it's mainly come from the communication, uh, electronics and communication domain. So they call it domain, but we have superimposed the electric flows on that. It's a smart grid is a interdisciplinary course. It's a interdisciplinary subject now. Even a power system has become interdisciplinary. Simply by having knowledge of power system now we cannot operate the power system. We need to have knowledge of machine learning. Optimization is without optimization, power system is nothing. Then computer and programming, blockchain, quantum computing is now another thing. So all these things are being used in power system. So power system is now no more uh, a core subject. It is becoming interdisciplinary. So we need to understand many more things. So, but for that, knowledge of power system is also must. And on top of it, we have to build our skill set to understand, to use those different domains to make power system more reliable. Okay, so these are different domains which earlier we had this transmission, distribution, and consumer. From generation to transmission to distribution to consumer. But now there are other linkages also. Yes, operation was there before also, market was there. We still have all these things. We have market, we have operation, transmission, distribution, generation, consumer. Now this service provider is a new entity. We still have it, but not at that big scale, only few. And companies are there and they are only providing very limited services. But the more we advance towards the smart grid framework, the more number of companies we will see which provide these different types of services. Now we can see, and I don't know whether you've heard, in different utilities in Europe or US, many companies have come up. One is Yes Market, Yes Energy, Modo Energy. Now they are providing these different services. They are keeping a close eye on the market data as well as the what is happening in the grid, and they are providing insights to the utility. So they have tied up with the utility and they are doing all kind of data analysis and helping them to predict, to do forecasting, to do predictive strategies, to make strategies. Especially in India, we don't have extreme winters. We have it in Himalayan region, but there even the uh, population is also less. We don't have that much transmission there. But in countries like US and Europe, the extreme winter events are now increasing, and which is becoming a challenge for them. Texas blackout happened because of extreme winters in 2021. So they want to prevent all these things. So that's why these new companies have come up, which are providing these different types of services. to help the utility predict in advance how much requirement. And you would have heard this term. I think this is when we talk about renewables, this term is the most common term. Uh, I don't know the exact pronunciation. It's a German term, Dunkelflaute. Have you heard? I think you would have heard. It's common in Europe. For 1 or 2 weeks, they will find solar. It's European countries are in the Tropic of Capricorn. So already the sunlight is very diffuse there. So solar penetration is very less there. So they mostly rely on the wind penetration. And during 1 or 2 weeks, the wind is there is no wind, very little. The wind speeds are very less, very low, and thus the wind generation reduces significantly for these 2 weeks. And this has happened with you, I think 2 weeks, 2 or 3 weeks ago in Europe. And so these companies are helping them to predict such kind of events and how to deal with them, tackle with them, how to plan for those 1 or 2 weeks. Another term which you would have come across is renewable drought. Right? Generally, we talk about drought in terms of this water when rainfall is not there, right? But we, when renewable penetration is high, this term of renewable drought is used. And especially in it came for uh, it was double in European countries or US because their penetration is quite high. And for especially in winters for 1 or 2 weeks, there is a drought, renewable drought kind of situation. And for that's why energy storage is picking up so much. You will see different types of energy storage in coming weeks. Then these are all these 7 blocks, 7 domains, and each of them also have so many components, functions. Like market has so many functions, trading, DR, aggregation. So this can be provided here that service provider will integrate with the market. And you would have heard of this EV aggregators, electric vehicle aggregators, or in future you will also see uh, demand response aggregators, or you would have heard this term of virtual power plant. Have you come across this term, virtual power plant?
Yes. Could you please explain this bit, virtual power plant?
So there can be different ways of having this virtual power plant. One way is to have like in the way in the context of aggregation I was talking about. So there can be a company, an entity, so it is called as virtual power plant, but what it will do, it doesn't have its own plant, no generation plant, but it will have contracts with different entities. And these entities can be energy storage, it can be small DERs, these can be electric vehicles, and they can also uh, uh, have what we call contracts with the different consumers, industrial consumers, even residential consumers. So these are these consumers are large in number because individual consumer is a small. Their consumption may be 10 kilowatt or something. Their
Is it just because of this the source of the power? That's why it's called VPP, or is it because of it can be any
Yes,
generation source?
yes, it can be any generation source, and these are
Because
generally uh, there will be different entities because it is called virtual power plant because this a power plant. When we talk about a physical power plant, there is a physical power plant and the company owns it. But here the entity which is called virtual power plant is not having its own power plant. It is not
It's
owning that.
they're actually
It is,
commercially transact the power, not physically, right?
yes, yes, correct. There is no physical transaction on its part. It is not providing physical transaction, but still it is able to do the demand supply balance by
Okay.
having
So,
contract with generators as well as demand loads.
just one more question. Uh, because in the recent market, there's a concept going in this, supply providers, maybe trading companies, they use
Hmm.
they call it banking. So how it is different? Banking is different than BPP.
And when you call about banking, so what do you exactly mean? I don't know about this term. That's why I'm asking.
Because banking was actually, what they're doing is they have a contract with the
Hmm.
generator, small generator.
Hmm.
Uh, uh, um, let's say I made an agreement with you and I will purchase 10 megawatt of energy
Okay.
today, but I will take your physical supply some other day.
Hmm.
In today's price, I have purchased your energy,
Hmm.
but I need this supply and some other day.
Yeah, this is a kind of a forward contract. Yes, this is a kind of a forward contract.
So
So,
that's what I'm
yes.
asking. Why, how VPP is different than this?
No, VPP can do the same thing. So VPP is a entity and it can perform several functions. So what you are saying is a part of it's one of its, you can say, function.
Okay.
It can do that. It will also have forward contracts with different entities. That will be there. Different types of contracts are there. Forwards contracts is there. Futures are there. Then contract for difference is there.
Mhm.
Now government is talking about the CFDs, contract for difference.
Yeah.
So there are different market models and different market products. So these virtual power plants will have a portfolio of different products. Not only just portfolio of different products, they have portfolio of different types of generation technology. And when we have portfolio of different financial products and different entities, different generators, and as well as different demand loads, then optimization, we have to optimize in such a way that we can make the profit. So all these virtual power plant will have their own strategies to get the maximum out of the contracts they make with these different entities. So
I have
yes.
good example of this, for this banking. I just remember right now. Back in the days, in 2 years back, what happened is these northeastern utilities are usually send their energy in the rainy season
Hmm.
to a service provider company at a certain price. And when the rainy season gone, the drought season, like in the winter, they need energy from other side. Then then these companies will fulfill their energy needs based on, it's not about the commercial transaction. It's about the physical. I have taken 10 megawatt of your your rainy season during my need, and you need this energy. I have to pay or give it for you. I mean, however I sourced it.
So they decide the price beforehand.
It's not about the price exactly, mainly.
Okay.
It's
It's
about
more
the
about
physical
meeting
supply.
the requirement.
It's about, yeah, meeting the requirement.
A nice, good example. So these are different types of products, and these entities can have several products, and they will use these products in such a way that they can make profit. Similarly, these energy storage, one energy storage, uh, one storage utility. So let's say one company is having a storage, and that storage may be very huge storage, 500 megawatt by 1 gigawatt hour. Such storages are available now. now they have several options. They can go to ancillary services market, they can go to capacity market, they can provide black start services, but they have to do it in such a way that they can make the profit, maximum profit. They have to take care of battery degradation also. Frequent charging, discharging will deteriorate the battery life cycle. So they have to ensure that. And also because different markets, they have different price volatility. Ancillary service market has different prices. The power market, energy market has different. Capital market, capacity market has a different price. And even the black start market, even that is providing a very good amount, but that will be only few days in a year. And there are certain companies, there are energy storages which have earned their around 40% of their revenue from 1 week itself. Recently in European, this Modo Energy is doing an excellent job on this. They are keeping track of all these things, how energy storage are earning their revenue from different sources. So they have to optimize. Similarly, this virtual power plant will also have to optimize all these things. How many contracts to do with which entity and for which time, because this energy storage can provide both generation and it can act as load also. Electric vehicle can do the same. Even consumers, because of demand response, we can do both kind of thing. We can reduce the demand because they will have a control over their, let's say HVAC, this AC air conditioning system. And now in future, everything will be smart. All devices will be smart. So we can tune them. Electric vehicle can also provide the same kind of services. So all these things we will see in future. Many companies will be there. So I want to give one impression that many people think that now power system is saturated. There is no more development in power system. That's why people are trying to opt for power electronics for doing MTech or PhD. But power system is now, as I told earlier also, that it is becoming more interdisciplinary and so many new opportunities are there. But for that, you will have to develop the skill set, not just power system. You'll have to learn these other aspects of economics, of data analysis, of optimization, and blockchain, and all these things, cryptography. All these things are required, quantum computing. But power system is now, these companies will come up. Many companies are coming up because these services are required. Okay. Yeah. Thank you
Exactly.
for your uh, uh, comment. It was a good example. Uh, Real
No
time.
problem. I've been working in this industry. I started learning this because I have this interest on this smart grid, and I think I will finish it. Let's see.
So if you have any one of you, if you have a suggestion how we can improve these sessions, then please let me know. So I
Yeah,
will try to.
it's good if you make it in more interactive one. So we
Yeah,
know.
so I was thinking that the content is already there in the week, and other
Yeah,
TAs are also going through the entire summary. So I was thinking that if I can give you more kind of updates and
yeah, yeah,
more up-to-date things, then that was the my way of thinking. And
yeah.
but
How
yes,
we
you
can
can
implement into the
suggest.
real time. That would
Yes,
be
so
great.
many real-time examples, and what I have been going through is I have been seeing, studying. So
Yeah, yeah, yeah.
that I will try to.
Some guys,
uh,
maybe you are working on some research papers. Please
Yes,
give
yes,
us
you
some
can.
insights
Yeah,
so we know that, and
correct.
we can
So
work on.
even
Now we also work with some organization, so we can share this knowledge with them, so we can improve this. How we can work on it, brainstorming, all the things.
yes, correct, correct. So thank you for, yeah. So it's good. We can, if we can interact, then we should have a good interaction and
Thank
make
you,
this
sir.
session more lively. Yeah. So trading, market operations, ancillary services. We'll see this in a subsequent slide. There are many ancillary services. And this ancillary services market is now coming up in India also. Recent ancillary services regulations, they have changed certain things, and energy storage is also now uh, it can also provide ancillary services. Okay, then this was service provider. Yeah, service provider. So many services can be. These are the options. So we can, any one of you, if you are willing to do some, want to do some startup, these are the options for you. And some of these are already existing, but now these will be becoming. They will be required in a more. Everything will be more automated. The home
Yeah, this
management
home
system.
management systems that are really new
Yes,
these
it
days.
is booming. Now,
Yeah.
so many technologies are coming up because in future, each and every apparatus in the home will be smart. It will be having communication facility. It will be connected to internet, and that's why everything you can now control through a smartphone. And the utility can also, if you have enter this service provider can, they will provide such kind of uh, products to you that it will be economical or even profitable for you to enter into a contract with them. So they will design, one research problem is to design these different products which a service provider can provide to the consumers.
Now, audits are going also important aspect is this in here. So
Where, sorry?
energy audits.
Yes, yes.
This audits is a particular service that also fits in this
Yes,
segment.
yes, correct. That is correct. That is also one of the services. It's very important. So emerging services, you can add that here. Audit and customer management, account management, billing. So all these different services are there. And then in operations, so many services, so many aspects in operations are there, and all these we have all these things in transmission system. In distribution system, we have them, but we are doing everything manually. Most of the things we are doing manually. Or we have, for reporting statistics, we do have some, like we use different, we have softwares for them, but as the data input increases, the software also needs to be updated. The fault management mostly in distribution system, it is manual right now. Monitoring and control is mostly manual. In Mumbai, Adani has recently installed one active distribution management system. It is it's very advanced. We can see everything in the distribution system and monitor everything. It's very advanced. Even a transmission in a transformer, you can even know the oil level of the oil in the tank. To such small details, one can have access to them by these advanced distribution management systems. So such things will be everywhere in the future. So there's a lot of scope for all these things. Then bulk generation, this we already know. And then transmission and distribution, distributed generation, the storage is a very important thing. We can see in both transmission and distribution, and we will see in the future I think 1 week will be dedicated to storage, where we will see different types of storage, their applications, and how storage will help us in achieving this, especially integrating more and more renewables into the system. And then the next topic was these different standards, because so many products are coming up. Standards are very important for interoperability, and so that the system works as per the desired uh, uh, in a desired band which we want. For everything, we need a standard because so many vendors are there, so many manufacturers are there. Each one will, if start producing their own, then it is difficult to combine them or have a communication between two different uh, products of two different manufacturers. So if we have a standard, then we can have a control of everything. The operator can control, means irrespective of the manufacturing company, or irrespective of the device, irrespective of the company which has developed front end or back end, the operator can work with that. It can control or even monitor it. So for that, standards are very important, and there are standard for each and everything. And these you can remember some. We'll see in questions these standards. And then last one was the elements and technologies of smart grid. So here we have already discussed the advanced metering infrastructure, then networking. So different, we saw the two types of communication topologies are there. One directly communicating with the utility control center. Another one is via the meter concentrator. So service provider will help in that case. Then smart meters, and finally the distributed automation system. This we will see again in the next week. So here what all components are required to make the distribution system automated. For that, the system, the system should be able to know, first of all, detect the fault. First of all, the prevent the fault. If fault is there, detect it, and then isolate the faulty section as soon as possible, as quickly as possible, so that the supply can be restored to the healthy sections, and then mitigate the fault section, and then even again connect it back to the healthy section. All these things, if it can happen automatically, that is the goal. That is the ultimate goal, that everything happens automatically. Right now, it's done manually. We don't even use reclosers. So all these things are there, and this is the one. And for this, we require these IEDs, intelligent devices, for each and every equipment that we have in the distribution system, so that we can know the status of that equipment and we can communicate with that equipment. Because if we want to automate everything, then these devices should be able to communicate with each other, and they should be able to work in a coordinated fashion to achieve the desired goal. Yeah, so this is, as you can go through it when I will upload the PPTs. So this is just they have, because HVDC was mentioned in the week, but so I thought let us put all the at present HVDC projects which are there in India. Total we have 13, 14 right now. And this Puglur Thrissur is the India's first VSC based, IGBT based HVDC system. And out of these, we have up to 800 kV. 3 are 800 kV, and these four are the back to back, which are connecting these different regions. So WR to NR, WRSR, ERSR. These are the back to back connections. This is one is this. Oh, sorry. One is this one and this. These three are the back to back connections. Yeah, you can go through this, and so there are different types of HVDC connections, bipolar, monopolar. I think you would have gone through this. If you have doubt, you can ask me in the next class also. So let us go through questions. We have 15 minutes. So let's start with the easiest question. Father of AC distribution system. It's very easy. Who is
Tesla.
father of?
Tesla.
Yes, and DC?
Edition.
Edison.
Edison. Yeah, there was this current of wars, famous current of wars. And finally, Tesla won because of the transformer. Transformer changed everything at that time. So now one question is, in AC we have transformers for stepping up or stepping down the voltage levels. In DC, do we have such things? Can we do it? Can we step up, step down voltages in DC?
Yes. Bug
How?
filters.
Yes, correct. Good. Yeah, so buck boost converter are one option, and but they have limitations. So we have another topologies also. So these are non-isolated buck boost and buck boost. These are non-isolated converters or choppers, DC-DC converters or choppers, and they can step up or step down in a ratio of 1:4, maximum up to 4. Beyond that, we have to use the isolated technologies, these topologies, the push pull, this flyback, and all this. Yes, we can in DC also we can achieve this, but that time it was not available, and so Tesla won. And also because a transformer and also this is induction motors. Yeah, this was the history. Okay. Yes. Next question is, which of the following is one of the key features of a smart grid? Limited sensors, pervasive control, centralized generation, electromechanical operation. This is also a very easy question.
Centralized.
So which one is the correct
Centralized
option?
generation.
Are you sure?
Pervasive control.
Yes, pervasive control is correct option because centralized. We earlier also we were having the centralized generation. Now generation
Distribute.
is decentralized because we are having generation. Just we talk that we have generation at all the levels now. Even at distribution level, we are having generation DERs. At transmission level, we are having generation, and we are having components like energy storage, which can act both as a load and a source, load and a generation. Now, uh, uh, the definition of generation is also changing. It is becoming more, I would say, inclusive. So pervasive control is correct. So we have smart grid. We know that communication is required so many for full observability of system. We require sensors. So limited sensor would not work, and centralized generation is also not correct. And because we are making everything automatic, so mechanical components will be as as less as possible. So pervasive control is correct option. So this is the difference. The conventional power system, we were having one way. Here we have two-way communication. Centralized, now we are having distributed generation. We have sensors throughout. It will be self-monitoring, adaptive, and self-healing also. Yeah, so two-way communication, and we have control of major assets and subsystems. Next question is, okay, so because of this, we have fast failure detection and restoration. I think this is question as per the data given in the week, that in the lectures. Total installed capacity of renewable energy in Indian power scenario as per MNRE 2022. So this is old data. This is as per what was there in the lectures. So anyone of you who has watched the lectures?
Is it 113?
Yes, I think it is 113. D, no, 250 is not correct. I think it is 113. So this is the updated version. You can go through the slides. I have put the links also here. You can go through these links, and every time this install capacity report by CEA, every month they revise it. You can get the latest uh, idea of generation capacity here, and this cover all India. This is a report by CA. Every year they release this annual report. Here you can find the information about peak, this about this peak deficit, not deficit, this electricity consumption. And this power sector at a glance, here you can find all this information. This peak electricity demand met and deficit. So now we have this diesel hydro RES, and this total peak demand, uh, it touched 250 gigawatts in May 2024. And net solar demand met was this much. So, so if peak demand is 250, so let's say this installed capacity is quite high, right? 250, and it is around 456.76. Difference is quite large. Why do we have such a huge difference? Can anyone tell? What are the reasons for this? If we want to make a peak demand of meet a peak demand of 250 gigawatts, we this data says that we need install capacity around 456 gigawatts, which is way high. It's around double, 2 times. Even as per CEA, the planning reserve margin is around 15%. Any idea?
Is it due to different climatic conditions and different load patterns?
No, but if we are talking only about the peak, let's say we want to meet a peak of 250 gigawatts.
Hmm.
But for meeting that 250 gigawatts also, we require such a huge capacity, install capacity. Because if we are able to meet the peak, then we'll be able to meet the other off-peak
Yes.
hours also. This statement is valid only when the renewable penetration is less. Maybe up to 30% or so. But as the renewable penetration increases, meeting peak demand only is not sufficient. It is not sufficient. Then the net demand is a challenge. Meeting net demand is challenge. Because of that, California blackout happened in 2019. 19 or 20? 2020 rolling blackout of California. So see, one reason is because not all the generators are on bar maintenance. Several generators are on maintenance. So out of the if
Why do we get
450,
electricity demand deficit then when generation capacity is much more than electricity demand?
then you're saying what will be there?
No, why it is showing peak electricity demand deficit at 0.01%?
Yeah, so yeah, I'm coming to that only. So even if we take 10%, right? 10% of what we say availability of these conventional generators, then 90% of time their availability is around 90%. 10% of times they will be on maintenance or some failure, some scheduled or planned or unplanned forced outages are there. Forced outage rate is around 10%. Then scheduled maintenance is also there. If we combine both of them, the availability factor is less than 90%. So even if we take it 90%, then 10% of this is not available at any time. So that is only 400 gigawatts. Still, it is 150 gigawatts more than the 250 gigawatts. Okay. This is very optimistic. It will be even less than that. Then we come to now, this is considering only the thermal generators. But in the energy mix, we have other generators also. We have hydro, which is not always available. Let's say peak demand is in summer. And at that time, hydro, although we try to keep it, uh, we try to save the water to meet the peak demand, but still it is dependent upon the geological factors. And if water availability is less, hydro capacity, install capacity, this generation will be less than the install capacity. Then the next is this, we have RES. In this we have solar, wind, biomass, cogeneration, all these things. And they are also dependent upon availability of their fuel, availability of irradiance, wind profile. And if we talk about solar, its capacity factor is around 20%. Wind capacity factor is between 20 to 30%. So if we have out of this 450, we will see how much around, let's say, where is RES is 158. So 158 gigawatt is renewables. So make it 20%. Let's say this is 160. 10% is 1632. So we have only 32 gigawatt of actual generation here out of 158. So this difference was 150, right? Out of 158, we are only having 32 gigawatt. We have not even considered this biomass cogeneration and hydro availability. So it might happen that due to some and it happens. This is very optimistic estimate which we have made. 10% availability, 20% is also on a higher end for solar. It is even less than that. Then operating, that's why we need a very high. We need, and more the solar and wind penetration is, the installed capacity will be much higher than the demand, actual demand, which is to be met. That's why sometimes we have a deficit, peak deficit, and we have to till the load because of forced outages, planned outages, and low capacity factors of these renewables. A solar plant may be rated at 1 gigawatt, but actually it will not generate 1 gigawatt. On an average, it will only generate 200 megawatts annually, annual average. So if that peak generation of solar coincides with this peak demand, then we are fortunate. But if it doesn't, then it will be a problem. For that, that's why we are emphasizing so much on storage, energy storage. Now, is it clear?
Yes.
Okay. So this is the updated bifurcation of these different energy resources. You can go through it. I will upload the presentation. Okay, let us move first. Overall network losses in 2016. So we have very high network losses. It was around 22.7%. And this is also available on this annual report. I have pasted the link here. You can go through it. For some states, it is very high, 42%, 44% for J&K. This is annual. This is all India average, 22.7. This we all know, 500 gigawatt. IECS, what does IEC stands for? This is an important question.
International Electrotechnical Commission.
Yes, correct. Wired communication system consists of, so out of this, which one is wired? Optical, fiber optic. Correct. The objective of ancillary service operation in market domain is what
Frequency
is
support.
provide frequency support. Yes, correct. Yeah, so these are all the ancillary services which are available. Frequency control, network control, and black start services. And energy, this is energy storage can provide all these services. All these services. That's why energy storage is becoming so popular. But different technologies will provide different types of services. But yes, energy storage can provide all of these.
Pump hydro are the playing very bigger role here.
Yes, in India has ambitious targets for, even in Maharashtra they have, MSCDCL has entered in contract with around contract of around 5 or 6 gigawatt of pump hydro storage. Because one problem with these inverter based resources is of inertia. Pumped hydro can provide inertia also. It can provide reactive power support also. And yes, it can provide long discharge durations.
Also, it
That
can
is,
solve the problem of the duck up.
yes, because of that discharge duration, it has a longer discharge duration. It's high energy density, technology. Pumped hydro storage has a higher energy density than these lithium ion technology and other technologies also. That's why we are emphasizing more on pumped hydro. And its life cycle is also, its lifetime is more than lithium ion, 15 to 20 years, most maximum 15 years. But a pumped hydro plant has a life cycle of 30 to 40 years.
Even more, even with proper maintenance, even more.
Yes, yes, it can even work up to 50 years, even more. There is one plant here in Maharashtra, Ghatkar. It's working since 1985. Okay, so you can go through this also. So PPT will be there with you. And which standard belongs to wide area situation awareness? VASA. 1547 is for DER interconnection of DER. This is for time synchronization. This is for AMU. All these. So these are the different standards. So this one, some important standards are these which you should always try to always remember. One is this 1547, 61400, and for VASA, this EMU measurement synchrophasers. This is the C37.118 and 61850 for substation automation, and this is for time synchronization. There is one more which we will discuss in the next week, IEEE 2800. This is for interconnection of DER at distribution level, and this is for interconnection of DER at transmission level. So people were applying the same standards for transmission level, and there were many problems. That's why IEEE came up with a new standard 2800. So that we will see in the next week. And so IEC 6 we have already seen that it provides uniform information exchange for monitoring and control of wind power. This IRIG-B is for substation automation for time synchronization protocol. Then yeah, this is already discussed. Which of the following quantities not measured by smart meter? We have seen what all quantities it measures. So which one is not measured? Voltage sag, correct. Voltage sag we cannot measure. So these are different power quality issues. Voltage sag is one of them. And in advanced metering infrastructure, each smart meter communicates with, this is very simple.
MDMS.
Yes, meter data management system. What is the function of smart information system?
All of the above.
All of the above, correct. In the smart grid, the distribution domain will communicate more closely with operation domain in real time to manage distribution and operation. To manage which one of these? So operations and distribution. Which of these will fall in operations category? Any idea? C, perfect correction. D, voltage profile. Power flow, right? If you know power flow, we can know other things also. The meter concentrator is responsible for supporting communication with the meters over. We saw the two types of topology, one directly communicating with MDMS, one through meter concentrator. This has one communication, this requires two types of communication. So which is this communication?
NAN.
Yes, neighborhood, correct. And the second one is LAN. Which of the following is guide for interoperability of energy storage? For interoperability of energy storage. This is a factual question. It's 1.2. So 2030.2. Grid assets are bought and sold in which domain? This is very simple. Markets. The standard, this also we have already seen, is 337.118. It provides method of evaluating a PMU measurement and requirement. This we will also see when we will discuss PMU later in subsequent weeks. How do we estimate the phasor estimation? That we will see techniques used for that. So the questions are over. The time is also, I have taken 8 minutes more. But thank you very much for patiently.
Tomato rice.
Do you have any doubt?
Same sound rather.
Can we have your contact for communication? Okay. So yeah, I can provide my email ID. Will that be fine?
Yes, sir.
Okay. One, two, one, one. Yeah, I have typed it in the chat box. You can contact me on this mail ID. Okay, any other doubt? So thank you very much for patiently hearing and waiting for continuously for 2 hours you were there. So thank you very much and I hope these sessions will benefit you and you can always tell me if you want to change something and we'll try to keep it interactive. I will try to keep up, things updated and so
Just one more question.
yes.
Could you please let me know how will be the this examination? I don't know. First time this NPTEL.
Okay. So the examination will be similar to the assignments, whatever you are assignments which you are getting, right? The questions will be similar to what we are getting in the assignments. So if you go through all the assignments and I will also we are discussing other questions also and in future, because this was a theoretical, first week was a theoretical content was there in the first week, but in later weeks some numericals will be there, some conceptual questions will be there.
Okay.
So if you attend these live sessions, you will benefit a lot. You will be able to answer most of these conceptual questions. Theoretical question, you will have to remember certain things that you have to remember yourself. But yes, important things we will mostly cover here in the live sessions itself. And in the end also, we will have one session where we will revise, we will take all the questions. So several important questions will be covered there also. Mostly it will be similar to the what assignments you get. So try to do them sincerely, seriously. And these live sessions will also certainly benefit you. All the questions will be MCQ, right?
Okay. Do you have any morning sessions in the evening?
Sorry, we don't have morning slots. In all the Monday to Wednesday and Thursday, we don't have any session. Right now, we are 3 TAs and 3 TAs. One session is on Saturday from, I think, 4 to 6. Today, Monday is from 6 to 8, and tomorrow, 5 to 7. These are the only 3 sessions. That's why we are also recording. You can see recordings, but for live interaction, you'll have to attend one of these 3 sessions.
Okay. Anyway, thank you.
Okay. So
Tomorrow, yes.
tomorrow, yes, 5 to 7. Another TA will be taking that session. The link
Sir,
is yes.
one more thing is there. I am attending another classes also. During examination period, we'll get time for attending the exam, or there will be some collision in that. If I will be having some collisions, I will get some provision to
You are
skip.
saying 2 exams same time.
Maybe same time.
No, I think
Because
this will not happen. But if this happens, you as soon as you get to know, you just tell them, notify them. This should not happen because they always make uh, this schedule in such a way that there is no conflict.
my one course is I think a colliding for
Means
examination.
exam date.
Yeah, exam date.
Oh, then I think you should tell them and ask them what should I do. They will tell you. You can contact the NPTEL team. They will certainly help you because
Okay,
they make that schedule, so we don't have any control over that. So you can ask them
okay, sir.
and please let them know now itself.
Okay, sir.
So next time they will try to ensure that this will not happen again. And yeah, where you will get the recorded session. Yes, you will get the recorded session in the problem solving session tab on the portal itself. On the left hand side bottom, there is a tab problem solving sessions. There you will get the link for all the Google Drive link, where you can find the link for the YouTube uh, link for this live session, as well as one Drive link for all the sessions PPT for all the 3 TAs. They will have their individual links. You can get all the links from there. Okay, so thank you very much. We'll hope to see you again next Monday. Thank you very much.
Thank you, sir.